All right, are you ready? It is the annual winter forecast video. Hey everyone, it's 21 News Chief Meteorologist Eric Wilhelm here. I am based in Youngstown, Ohio. If you're a new viewer to my content, welcome. I'm based in Northeast Ohio, and this forecast is going to largely focus on Eastern Ohio and Western PA. We're going to take a look at global things as well as we kind of explain why the forecast is what it is. This annual winter forecast will mostly cover meteorological winter, December, January, and February, although our snow forecasts are kind of first flake to last flake. I will warn you that this will be a long, detailed video. If this isn't your kind of video, if you just want something short and to the point, I would recommend you watch the TV version of this winter forecast. You can find that on wfmj.com/weather right now. But this video is going to go into a lot of detail. It's geared towards weather geeks, maybe other meteorologists, as well as those who need a lot of detail in their winter weather forecast. Maybe your business depends on accurate and insightful and detailed winter outlooks. So let's get to it. 2023-2024 winter. Will it be like last year, which was honestly a pretty lame winter? Will it follow the trend of recent winters, which have generally been pretty mild? Well, let's see. Let's talk about briefly last year's numbers. It was a remarkable season last season. It was the third warmest winter on record for our area, the second warmest February, the second least snowy February. We had less than a half an inch of snow at the Youngstown Warren Airport in all of February. Now, that is pretty remarkable to go almost all of February with no snow. January was the fifth warmest on record, and February, not only did it not snow much, it was pretty bright. That's not typically the case around areas downwind of the Great Lakes in the winter, of course. It's one of the cloudiest places in the country, but we had the seventh sunniest February on record back at the end of last winter. So the final numbers at the Youngstown Warren Airports last winter, 22.8 inches of snow. That is a full 45 inches shy of average. We average, our 30-year average is about 67 inches worth of snow in a season at the Youngstown Warren Airport in Vienna, Ohio, which is about 10 or 15 minutes north of downtown Youngstown. Temperature-wise, 5.9 degrees above the average is the final number for December through February of last winter. Now, how does, I mentioned the airport typically sees about 67 inches worth of snow as far as a 30-year average goes. Region-wide, though, when we're looking at Northeast Ohio and Northwest PA, a typical season for snowfall, it's not uncommon to see triple-digit numbers up in the primary snow belts. The primary snow belts of Northeast Ohio are primarily just east of Cleveland, heading over towards far Northwest PA around the Erie area, and that primary snow belt, of course, extends up into western New York, close to Buffalo. In our television viewing area, which is basically this area, we typically see a gradient from north to south of roughly 30 to 40 inches in our southern areas, and as much as 70 inches, 80 inches even, in our areas that are closer to the primary snow belt of Northeast Ohio and Northwest PA. That's the 30-year average, though. Now, last year, we told you what happened. How did our forecast do? Not very well. Does that mean we can't do these forecasts? No, but it's the nature of the beast. A long-range seasonal forecast is a much, much different thing than the typical 7-day forecast you see me or other TV meteorologists do on TV each day. These are harder. There's a lot more that goes into them, and, of course, they're not the same flavor of forecast. We're not going to say it's going to snow on February 17th, and there's going to be 5 inches. We can't do that three months ahead of time. Seasonal forecasts are all about trends, things compared to average, whether it be precipitation or temperatures. And last year, our forecast for the averages, we expected it to be a wetter than average winter. We're going to give that forecast a C. It was actually reasonably close to average in terms of total precipitation, rain and melted snow. Our forecast for near average snow last winter, bad, D-, because as I said, it was one of the least snowy winters on record. Near average temperatures last winter was our forecast. It was almost 6 degrees warmer than the average, so that also did not pan out. Why was the forecast so bad last year? It wasn't just mine. Generally, in the weather enterprise last winter, forecasts went sideways in a hurry. The reasons are pretty complicated, and I could do a whole video on them. Had a lot to do with some things in the atmosphere going on in Asia that had downstream impacts over the Pacific Ocean, which impacted where the jet stream was aimed, and everything just went sideways, especially after Christmas and heading into the new year. So that's kind of, partially, or just kind of the Cliff Notes version, if you will, the reason why last year's forecast was such a titanic bust. We're hoping to do a lot better this year. Of course, the recent trends with our winters have been warm. We had a very average winter back in 2017, 2018. Otherwise, we've been at least a half a degree above average every winter since the super El Nino winter of 2015, 2016. Last year takes the cake, of course, at 5.9. But as you can see, ever since we kind of flipped the switch, we had a lot of cold winters back in the 2000s. But we flipped a switch about halfway through the previous decade with the Super El Nino coming on, and ever since then it's been really hard to get even an average winter, not only here locally in eastern Ohio and western PA, but in much of the eastern parts of North America. So how do we do these? Again, this is a different way of forecasting than the kind of forecasting we do on a day-to-day basis for television purposes. We rely a lot on what we call analogs. We look at previous years with similar conditions in the oceans and the atmosphere to what we have in the lead up to this coming winter. We're going to talk about El Nino a lot in this video. That's one of the ingredients this year. We do rely on some computer models. There are seasonal computer models that run out several months ahead, or several months into the future, I should say. We use those carefully because just like any other computer model, even models that only run 18 hours in the future, those models are going to have their flaws. They're going to have things wrong with them, and they're certainly not the answer key. But we use them as a tool. And with this comes a lot of, intuition as you gain experience. You theoretically learn from past mistakes. I learned from some of the mistakes we made last year with the forecast. This year's forecast, one of the things I'm guarding against is a mistake I made a few years ago back in 2019, 2020 with regards to what's going on in the Indian Ocean right now. Again, we'll talk about it. But that's one thing I carried with me from a previous forecast that went a little bit astray about 4 years ago. All right, so key player for this winter, it is El Nino. It's the warming of the waters in the equatorial Pacific Ocean. It's the opposite phase of La Nina, which has actually been the phase we've been in the Pacific for the last 3 years. We had back-to-back-to-back La Ninas in the Pacific, but the switch flipped in a hurry this year. We went from a pretty stout La Nina to now a pretty stout El Nino. At the beginning of November, we were at the edge of the strong category in terms of the strength of El Nino. This is not going to be as strong of an El Nino as that super one we had back in 2015, 2016, but the overall numbers are probably a little bit stronger than a couple of the more recent strongish or moderate El Ninos in the last 20 years or so. Those two are 2009 and 2002 as well. The raw numbers are probably going to be a little higher than those two, but not quite as high as 2015, 2016. But the question is, will El Nino behave in a way you would expect with a fairly strong signal or a fairly strong El Nino? And the jury is very much out on that, and there's a couple reasons for that. We don't just look at El Nino when we are looking at the global oceans. Here's your El Nino right here. There's your warm tongue of water. It's important not only how strong El Nino is, where the warmest waters are centered. Are they centered closer to South America over here, or are they centered out here in the Central Pacific? Right now it's more towards the Eastern Pacific. Elsewhere though, see this blue right here near Hawaii, and a little bit of a blotch of blue off the coast of northwestern United States and western Canada? That patch of cooler water is pretty unusual to have during El Nino. The strength of that tongue of cool water, it's called the Pacific Decadal Oscillation. The strength of that right now is really unusual during a pretty stout El Nino. The other thing we are keeping a close eye on is this out here, this blue in the Indian Ocean. This is called the Indian Ocean Dipole. Right now, it's in a very strongly positive phase. In other words, we've got a lot of cold water in the eastern Indian Ocean. What in the world does that matter for us? This phase of this Indian Ocean dipole has implications downstream across the Pacific, and we last had this in 2019. We ended up with a really warm December. Past instances like this have resulted in pretty warm Decembers across North America. So Indian Ocean important, this cool water here important, in that it might modulate El Nino a little bit and actually neuter it a little bit. In other words, El Nino might behave ultimately a little more like a weaker El Nino than a strong El Nino, because we're a little bit out of sync here in terms of these ocean water temperatures across the Pacific. So that's kind of an important wild card for this winter season. Now, every El Nino is different, right? Here's some of the more recent ones and what the outcome was in the winter for our area. We had a weak one back in 2018, 2019. It was a somewhat warmer than average winter and below average snowfall. The Super El Nino 2015, 2016, of course, it was very warm, pretty snow free. Before that, though, a lot of these El Ninos more recently were pretty cold and pretty snowy. None of these were strong. We had a couple of moderate ones, 2009 and 2002, but none of them were strong. So we have to keep that in mind. But in recent history, more often than not, when you have an El Nino phase, that's a pretty favorable signal for cold and snow in our area. But again, it's all about the strength. If you're rooting for cold and snow, you want El Nino, and you want El Nino to be on the weaker side. The stronger it is, usually, the better chance you have of the outcome being a pretty warm winter. 3 of our warmest winters on record were strong El Ninos. A couple of these really strong. 82, 97, 2015, all 3 years really strong El Ninos. This list over here is our coldest winters. Look how many weak El Ninos are on that list. So again, if that's what you're rooting for, that's kind of what you want. All right, so we talked some about the oceans and the water temperatures and the anomalies. Let's talk about a few other factors going into this year's forecast. Sunspots. What does that have to do with anything? Well, some long-standing research strongly suggests that when we're in this phase of the sun cycle, the sun goes in 11-year cycles, where it gets quiet. In other words, there's not many sunspots, and then the amount of sunspots ramps up. When the sun is active, when there's a lot of sunspots, that can actually do things as far as the solar particles coming towards Earth, and it can actually mess with the upper atmosphere a little bit. It gets kind of complicated. But research has shown when we're in that increasing phase of sunspot activity, like we're in right now, when you pair this with what's going on with stratospheric winds way up in the atmosphere, when they're in a certain phase, that can increase the odds of blocking patterns in the northern Atlantic Ocean and a weaker polar vortex. When you have blocking patterns and a weak polar vortex, it's a little easier for cold air masses, true Arctic air masses, to meander off the pole and come down into the mid-latitudes with a little more frequency. Does that guarantee cold where we are? No. The mid-latitudes could be the mid-latitudes of China, could be the mid-latitudes of Europe, but it could also be the mid-latitudes of the United States. So one thing going in our favor, again, if you're rooting for cold and snow this winter, is this phase of the sunspot cycle we're in, paired with what's going on high above our heads. This is called the QBO, the quasi-biennial oscillation, basically a belt of winds around the equator. This is a naturally occurring phenomenon that reverses phase roughly once every 18 months. When it's or 14 months, I should say. When it's in its westerly phase, that increases the chances for a stronger polar vortex and milder winter weather in the eastern U.S. When it's in the phase it's in now, which is negative or easterly, and especially if you pair that with the solar cycle that we're in, that can increase the chance of colder outcomes in the eastern U.S. And actually, I have this graphic wrong. Right now, we're in a strengthening easterly direction and not westerly. All right, so that's an argument for a weak polar vortex blocking and maybe more cold this winter. Let's make the opposite argument. Let's talk about the argument that the polar vortex may be stronger than usual this winter, and a stronger vortex would lock up a lot of the cold air up over the Arctic. This is a satellite picture of a volcanic eruption almost 2 years ago. This was in January of 2022 in the western Pacific Ocean. Now, this volcano mostly erupted under the water. And instead of spewing mostly sulfur up into the atmosphere, it actually spewed an enormous amount of water vapor because it was largely an underwater volcano. It spewed a whole bunch of water up into the atmosphere. And that water has kind of been circulating in the high reaches of the atmosphere now for almost 2 years. Initially, since this was in the southern hemisphere, it was largely, that water circulating was largely over the southern hemisphere. But in recent months, and really all of 2023 almost, it's been reaching more northern latitudes. So here's a look at water vapor concentrations by year at 75 north. So we're in the northern hemisphere. We're pretty high up there, way up in Canada, almost to the Arctic Circle. You'll notice the darker greens here this year. That's that water vapor spewed by that volcano. Now, you may have seen, not only do we have climate change, of course, and long-term trends have definitely been in the warm direction, but the numbers this year globally for temperatures have been eye-popping. They've been astronomically high, even on top of the long-term warming. And there's been a lot of speculation. It's not confirmed necessarily yet, but there's a strong argument to be made at this point that this water vapor concentration has done a number on global temperatures this year. Water vapor is a very effective greenhouse gas. It's a naturally occurring greenhouse gas, but it's a greenhouse gas anyway. It's a very good one at retaining heat in the atmospheric system. And there's a good argument to be made that this year's weirdly high temperatures across the globe have something to do with this water vapor. The other thing that this water vapor may end up doing is strengthening the polar vortex, because the water vapor can actually serve to cool the stratosphere, and a cooler stratosphere would mean a more well-defined polar vortex spinning around up there, not getting wobbly, not getting loose, kind of hogging all the cold air and keeping it up over the pole. It'll be very interesting to see what happens over the next few months. This is newish science. It may end up not having much impact at all, but I think there's a reasonably good argument to be made for both of these things, both what this water vapor has been doing to global temperatures and the idea that we would have a stronger polar vortex this winter. We shall see. So, mention those analogs, those past years with a lot of similarities to this year. No analog is perfect. A lot of these analogs I would say are like, C, maybe B minus analogs. They have some similarities, but not a perfect match. Probably the best analog overall, even though it's not perfect, probably the best one is 2009, 2010. If you remember from earlier, talked about, that was a pretty cold and snowy winter. Temperatures that winter, 2 degrees below average, had about 8 inches more snow than the average that winter. That's probably our best analog, but it's not perfect by any stretch. Some of these other years, in some respects, are better analogs than 2009, 2010. Some of them are worse. Overall, 2009 and 10 checks the most boxes. Here's our list of best analogs. When you average together all those analogs, you end up with an average of about half a degree warmer than average, and snow a handful of inches, I should say, less than the average. When you plot all those analogs up on a map and weight those analogs for the ones you think are the best matches. In other words, 2009, 2010, you'll see at the top here. This is on here a few times. We included this in this analog composite a few different times because it is the best analog overall. When you plot all that up, this is what it looks like as far as a national map. These are temperatures compared to average. The overall theme, cooler than average conditions, especially favored down here. Warmer than average conditions favored near the US-Canadian border, something like that. Overall, that doesn't stray too much from long-term El Nino averages. That's kind of an El Nino flavor to a national temperature map in an El Nino winter. All right, so we talked about analogs. We also look at weather models, and we're going to show you just a couple because we could show you a whole lot, but we don't want this video to be 2 hours long. Here's a look at this was just issued a few days ago, the latest version of the European model seasonal forecast, December through February, temperature anomalies. It kind of looks similar-ish to the analogs, with warmth definitely favored up here. Now, these long-range models have a harder time displaying graphically for some reason, and I'm not sure what it is. They have a hard time displaying graphically cold anomalies. So if you imagine in the heart of all this white down here, some blue, that's probably actually what the model is seeing, but it just is not displaying it graphically. So it gives you a little more confidence when the models are agreeing with your composite analog set. In the European, generally, it's pretty close. Same thing with the Canadian model. This is kind of the Canadian version of what I just showed you. Pretty similar. There are some differences, sure, but overall the idea of warmth compared to average in Canada and cooler conditions perhaps favored in the southern US and our area maybe being somewhere in between, you can kind of pick that out on the Canadian model. Again, there's a lot of models out there. Those are just a couple. All right, so let's show our cards. Let's get to the forecast. Let's put some numbers on this thing. The odds of certain outcomes when it comes to temperatures. The top two boxes, these are the colder outcomes. I think there's about a 1 in 4 chance that the winter as a whole, December through February, ends up being more than a degree cooler than the average. I think there are somewhat higher odds, probably 40%, that the ultimate outcome, December through February, is at least a degree warmer than the average. And I would put the odds of it being around average at about 35%. Are we calling for a harsh winter? No, we're not. But I do think there'll probably be some harsh periods, particularly after the first of the year. We'll break down the month by month in just a second. Now, in terms of snowfall, the numbers are kind of similar here. Roughly 25%, 1 in 4 odds of a pretty snowy winter. Maybe somewhat higher odds on the order of 45% of a somewhat less snowy than average winter. And about 30% odds of it being just a pretty darn close to average winter in terms of snowfall. All right, so when we break this down month by month, let's first take a look at the winter as a whole. Here's our December through February forecast. Cooler than average temperatures favored, where you see this kind of pale blue. Up here near the U.S.-Canadian border, warmer than average favored. You can see we're kind of right on the edge of that warmer than average zone in our area. But that's just the winter as a whole. That's a long season, 3 months. There can be a lot of variation. Let's break it down month by month. Due to the fact that we have that strong Indian Ocean dipole I talked about earlier, and we have El Nino, both things usually conspire to produce a pretty mild December across the eastern U.S. And this is something we're pretty confident of. That while sure it's December, there's going to be days when it's going to be pretty cold outside. The month as a whole will not be anything remarkable temperature-wise. That's the way it looks right now. Now, as we go past the first of the year, this is when the pattern may start to become much more interesting east of the Rockies, and particularly as we get into the latter portions of winter. This is when more cold outbreaks would become more likely. Perhaps if we get some blocking patterns in the Atlantic, if the polar vortex is going to weaken and meander, this is more likely to be when it's going to do it. As we get into the back half of winter, later January, into especially February. You notice February is kind of the opposite graphically here than December was. December, warmer than average, definitely favored. February, my money right now is on that being easily the coldest month compared to the average of the 3 winter months. It's happened a lot in El Ninos. You see it show up in a lot of our analogs, and you see it showing up in some of the modeling right now. That odds tilt in favor of our most frequent bouts of cold and snow, perhaps coming towards the back half of winter. All right, so our snow forecast. All of these numbers, no matter where you are on the map here locally, are a little below the average, but not by much. 10%, maybe as much as 25%. But all these numbers should be much closer, much more in the neighborhood of average than last year, which was ridiculous. So if you're watching from our southern viewing area, probably 20 to 30 inches of snow for the winter. Up in our northern viewing area, Kinsman, Mecca, Greenville, closer to the snow belt, 70 plus, pretty likely. Our official reporting site at the Youngstown Warren Airport in Vienna, down in here, it's probably going to be something like 50 to 70, somewhere in that neighborhood. Again, average is about 67. I would put the most likely range at around the airport of 50 to 70, with less south and more to the north. All right, so how does this compare to last year when we just boiled all down and make things real simple? Here's just a 4-quadrant graphic. Last year we were way up here. Now this year we might be in the same quadrant, but much closer to the middle. Are we going to be down here? No, I don't think so. I don't think this is going to be like a winter in the 70s, or even more recently 2014, 2015, which was a harsh winter. I don't think that's the flavor this winter. And maybe the flavor at times after the first of the year, but the winter as a whole, probably not. But again, while we may be in the same kind of quadrant up here as last winter, it's probably not going to be a winter that you're going to be bopping your grandkids on your knees talking about years and years from right now. So bottom line it for you. We're at 23 minutes. This might be a record this year for the length of this video. It's a complicated forecast, but we'll kind of wrap things up here. We do think that a mild/warm December is very likely. Does that mean every day is going to be shorts weather and ridiculous? No, but the month as a whole probably is a fair amount warmer than the average. As we go to the first of the year, though, everything can change. January and February, potential is there for more cold and more snow than we've seen in a lot of our recent winters, and especially last winter. A harsh winter, flavor that we had in the 70s, flavor that we had a couple of times about a decade ago, that is unlikely, but more typical than the last several years. All right, what can go wrong? Well, lots can go wrong with a seasonal forecast like this. If the volcano ends up having a much bigger impact on the polar vortex than anybody sees coming, and the polar vortex just stays strong all winter, a warmer outcome could be the result. The ridiculously warm temperatures we've seen globally this year, if that trend does not change and it just rolls through the winter, then we can probably forget about any sort of sustained memorable cold even after the first of the year. What about colder outcomes? Well, if the volcano really didn't have much impact at all on the polar vortex, the solar cycle, the QBO those end up being overriding factors. The polar vortex is weak and meandering around. It could be really cold at times, particularly again after the first of the year. If the El Nino behaves much more like a weak El Nino, or even more like La Nina, that could result in more cold than we're bargaining for. Again, particularly later in the winter. If El Nino ends up being pretty strong and the La Nina hangover, if you will, in the Pacific ends up being not a big deal, then a warmer outcome could happen. So again, there are caveats. Things can go wrong. We put these forecasts out, and it's our best estimation at this point as to what will happen. But anything and everything can happen when we're talking about seasonal forecasts. So again, thank you for watching. If you want even more content and more detail, if you want to read about the winter forecast, I'm going to put a blog post up this evening, not long after this forecast posts online, this video posts online. So you can go to my blog, it's ericwfmj.com, and find that blog post. So thank you for your patience. Thank you for watching. Wish me luck. We'll need it. Hopefully we're not eating humble pie in a few months. Thank you again for watching, everyone, and I will see you later.